Alright, so let's learn how to create a classic load balancer with HTTPS listeners. Okay, so in the previous video, we learned how to create a classic load balancer on HTTP listeners. Okay, so the listeners actually dictates the protocol and port that the client will be connecting over. Okay, so if you have listeners on port 80, meaning the client will connect on port 80. If a listener on port 8080, the client will connect on port 8080, okay? And we integrated our classic load balancer, the Route 23, so that the client can use our custom domain name rather than AWS provided DNS name for the load balancer, okay? All right, so what we're gonna do is pretty much simple. I'm just gonna change this one to port 443. HTTPS 443, copy that, and maybe as well this one has to be 8443. Okay, then now here make it HTTPS, okay, and as well here make it HTTPS, then the port to be 8443. Okay, despite our Python servers are running port 80, HTTP port 80, we can access our resources over HTTPS because the classic load balancer here supports what we call SSL termination that we can use actually to secure access to our resources by creating HTTPS listeners on port on our classic load balancer. Okay, all right, so the client will be hitting the URL this one. Okay, then Route 3 as our DNS provider will do DNS resolution and finds that this record actually points to our classic load balancer. Provided that the classic load balancer is configured on port HTTPS port 443 and port 8443, it will do SSL termination and forward an encrypted packet to the backend over port 80. Okay, so when the packet comes back on port 80, when the request comes back on port 80, when the response comes back on port 80, classic load balancer will encrypt the packet and send it back to client on either port 443 or port 8443. Despite doing load distribution or load balancing on our servers, classic load balancer, we can use it to secure our servers with SSL certificate. And the requirement here, we need to have an SSL certificate. Okay, all right. So the first step that we're going to do is to ensure that you have at least 2 servers running at the backend. And those 2 servers, you can deploy anything. Maybe your website on port 80 or any custom port. But in my 2 servers that I have currently, I've deployed Apache web server on port 80 HTTP. Okay. All right. So I'll go back to our AWS management console and seems like so this I think that's the previous load balancer I had. All right, so I'll create a new classic load balancer. So if you click create classic load balancer, now we're under HTTPS. Okay, in the next video TCP and finally SSL. Okay, let's do HTTPS. Click create and I'll name it CLB2 to be internet facing. Okay, because we want to access the load balancer over the internet, not internally. Internally means inside the VPC. The client should be or must be inside the VPC. Okay, or maybe if you've done IPsec VPN, transit gateways. Yeah. So in this case, let's go with internet facing. Okay, and then choose the correct VPC. And choose at least 2 subnets, okay, right, which are in different availability zones. Then ensure you choose correct security groups. Okay, all right. Then let's go back to our architecture. We need to have two listeners, port 443 and port 8443. So it should be HTTPS port 443. Okay, then instance protocol. This tells which port and protocol does your backend servers are listening on. The Apache web server by default listen on port 80 HTTP. Let's get another listener on port 8443. So that will be 8443. Okay, the backend port and protocol remains the same. Okay, all right. Now, because we're using SSL, we need to choose SSL certificate. And in this regard, I'm going to choose the wildcard certificate. Ensure you have a certificate in your account. Okay, the health check port. This is very important part. The health check port is this one. What does your backend running on? Port 80. Okay, and default Apache path, as you know, the default Apache path here, it's always this one. Okay, and now this file is actually there in that particular direction or directory. Okay, so LTX basically is a mechanism that the load balancer used to test whether the registered targets are actually listening and ready to present to serve traffic. Okay, so that's okay, we leave it that. Then we register our targets. So I already have two servers, Ubuntu servers. Okay, and I've configured, I've deployed Apache web server in those particular servers. Okay, then just confirm and create. All right, so if you go to our classic load balancer here, I want to inform you about few things. So you can see the status is still 0 out of 2 services instances in service. Okay, so we have to wait until the status is okay before we test. So like I mentioned, AWS provides you a unique DNS name for any load balancer that you create. So you can also use this DNS name to test your application. Okay, all right. So let's go to listeners. So like I mentioned, we have two listeners here on port 443 and port 8443. Okay, HTTPS. Okay, then our servers are running Apache on HTTP port 80. Okay, this is the ALB security policy, and as well the certificate that you've just chosen. Okay, all right. I think that's now okay. Go to network mapping. It tells us about the VPC and the availability zones, all subnets. Go to security tabs, the security group that we're using. Go to health checks, like I mentioned. Periodically, the load balancer test whether the registered targets are available and ready to serve traffic. So it will ping the servers on HTTP port 80 and the path of this one. Okay, all right, on every 5 seconds. Okay, so if the server does not reply twice, it will mark it unhealthy. But if the server replies 10 times, it will mark it as healthy. Okay, target instances, we have two target instances which are still registering. Okay, all right, so let's just see. Okay, here it is. I think now it's okay. I don't know what happened, but now it's okay. They've now registered. Go to monitoring. This way we can see CloudWatch metrics regarding LT targets and LT targets, latency, errors on the load balancer, and attributes where maybe you can configure connection idle timeout, connection draining, close on load balancing, etc. Okay, so our load balancer is ready to serve traffic, and we can try to test without this one first. Okay, let's test at the classic load balancer level. Just copy the DNS name and paste it there, and ensure it's HTTPS. Okay. Okay, you see, why are we getting the error? Why? Because the Amazon provided DNS name does not match our certificate that we've configured the load balancer. Okay, but after all, we are able to access our backend servers. So let's try on port 8443 as well. Okay, see, same thing. All right. So to avoid this certificate error, let's create a Route 53 record with this domain name. Okay, because you can see Amazon provide a domain name of that ends with amazonaws.com, but the load balancer has been configured with a certificate that ends with that one. All right, so let's go to our Route 53 and create record. Just search Route 53 and hosted zone, choose the hosted zone and create record. And this one was our CLB2 and it's a record type. Tick alias, then choose classic load balancer. Okay, then the region is US East 1. Go to your classic load balancer and the region where you've deployed it. Okay, all right, now choose your classic load balancer, which is CLB2 and create. Perfect. So here is our CLB2. So whenever we hit this domain name on either port 443 or port 8443, the Route 53 will do DNS resolution and forward that traffic to classic load balancer. Classic load balancer will decrypt that traffic and forward an encrypted traffic to the servers, because the servers are listening on HTTP port 80. The servers will respond with the traffic on with the response on port 80, which the classic load balancer will do TLS termination again and forward the response in HTTPS. All right, so let's just click status to see whether it's in sync. Perfect, now it's ready. Let's go back and mark on our record and copy the record name and try to hit here. Perfect. Now if you go here, you're seeing connection is secure and you click there and check certificate, you will see certificate is from that guy, which is our valid record on Route 53. Okay, and we can see more about that certificate. Okay, so even if you try on, it was 8443 but still HTTPS. Okay, and hit enter, you see you're getting traffic. Even if I go into incognito, yep, so just assume that you deployed your website in these two servers. So that's how you can access your backend servers securely using classic load balancer, Route 53 and Route 53. Okay, perfect. Thank you so much, guys. So in the next video, let's learn how to configure a TCP listeners on classic load balancer. Okay, all right, thank you so much and have a good day. Bye bye.